So we'll continue into 5.7. This is the order I'm going to go through in chapter 5. So we talk about what is a matrix or matrices for plural, and their operations, adding, subtracting, and multiplying. Typically, a matrix, sometimes it's just a box of numbers, or sometimes you give it a name, typically a capital letter. So a matrix is made up of, this is just an arbitrary matrix. You have rows, rows horizontal, numbers that go horizontally, and you have columns that go up and down, vertical. So this particular matrix has 2 rows and 3 columns. So we say that it's a 2 by 3, that the x means 2 by, or the x means by. So 2 by 3, 2 rows by 3 columns. That's the order of the matrix, its size, or its dimensions of the box. Aij, theoretically, the little I represents what row the number is in. J represents what column the number is in. So Aij means a number in the ith row and the jth column at the same time. So, for instance, in this matrix, A23 means what number lives in the second row and the third column. Well, that's -6. So A23 would be -6. For instance, 5 would be A13. 2 would be A11. 3 would be A21. -1 would be A12, etc. Again, as it says here. Now this is just made up of one column and 4 numbers vertical here, but there's also by default that's 4 rows. So row 1, row 2, row 3, row 4. So this is A11, A21, A31, and A41, and that's what the numbers are represented there. Nothing to solve, just definition, just vocabulary. So it's a 4 by 1 because it has 4 rows and 1 column. Now, to take 2 boxes, 2 matrices that you see down here, and to be able to add them or subtract them, you have 2 matrices that have to have the same order. They have to be the same size, the same number of rows, same number of columns. If they are, then you add or subtract the corresponding entries of the first matrix to those of the second. If the 2 orders are different, then you cannot do it. You write not possible. It's not possible to do. So if you take this box and add it to this box, notice that this first box has 2 rows and 2 columns. The second box has 2 rows and 2 columns. So they're exactly the same size. So we take the first number in the first row, first column of the first matrix, add it to the first number in the first row, first column of the second matrix. Then the second number in the first row, add it to the second number into the first row of the second one. Then the second row, first column. I'm sorry, this is the first row, second column, added to the first row, second column over here. Second row, first column, plus second row, first column, so -3 plus 5. And then the number in the second row, second column of the first matrix, plus a number in the second row, second column of the second matrix. So you do these 4 additions. 5 plus 6 is 11, -4 plus 8 is 4, -3 plus 5 is 2, and 2 plus -6 is -4. That's it, and that's all. That's how nice this is. So now this run has 4 rows and 2 columns. The second matrix has 4 rows and 2 columns. So you can do this. You can subtract or add. Here as well, you can subtract or add. Now, this one, you're going to do the same thing you did in the first one, but instead of adding them together, you're going to take away. So it has 7 minus 4, then 3 minus 8, then -8 minus -3, then 4 minus -5, 2 minus 2, 9 minus 7, 0 minus -1, 6 minus -5. This becomes 3, then -5, -5, then +9, 0, then 2, 1, then 11. And those are your answers. Notice the third problem here has a 3 by 3 trying to add to a 2 by 4. They're completely different orders, so the addition is not possible. You cannot add or subtract 2 matrices if they do not have the exact same order. Okay, that's essentially how it works. That's all this is. It's really nice. That's why I did 5.7 before I did 5.3. Okay, 5.7 continued. We're going to multiply a matrix by a scalar. A scalar is a fancy way of saying just a real number, just some number. That's not imaginary. That exists. To multiply a number by the scalar, multiply every number in the matrix by the scalar. So if I take this number 3 and I multiply by this box, I'm just basically taking 3 times each of these 4 numbers. And so that's what I did. So 15, -6, -18, and 24. And that's your final answer. That's all she wrote. That's super nice. And again, now the same idea. Instead of putting all the arrows, I just say, you know what? You can kind of visualize it. -6 times all of these numbers. So you get, what, -48, -24, +30, -18, +12, -6, 0, and -54. This one, when you multiply by 1 over a number, a fraction, 1/4, 1/2, 1/3, whatever it is, 1 over something, you put each of these numbers over 1 and multiply a fraction across and across. Now, this is 8 over 4, so it's 2. This is -3 over 4, does not simplify. This is 5 over 4, does not simplify. And this is 4 over 4, which is just 1. So that's all it is. You're just multiplying a number to a matrix. Typically, this is a special type of what's called a vector, and they're dependent upon forces. So this might magnify the force by a factor of 3. This might change the direction. This might shrink the force. So it has a lot of applications, but for the algebra, we're just kind of learning how this works. So now multiplying matrices. To multiply two matrices, the number of columns of the first matrix has to match the number of rows of the second. So in other words, the second number here has to match the first number over here. If those two numbers match, the interior two numbers, you can actually multiply. If they don't, then you cannot. So if they do match, we're going to multiply rows of the first matrix times columns of the second. So it's like I'm going to take this one and I'm going to distribute to each row. I'm going to pair them up because there's 3 going across, 3 going down. I'm going to pair them. One with the 1, 2 with the 2, 3 with the first number, the second number, and the third number of each. And I'm going to distribute to all of them, including the rows. So the outer two numbers tell us how big the answer is. So the answer is going to be a 2 by 4, which is 2 rows and 4 columns. I don't know if you can see that because I kind of zoomed out a little bit and I wrote it small. But hopefully you can see where these numbers come from. I'm going to take these, again, to get the first row, first column here, I'm going to multiply this first row times the first column. So these 3 numbers going across times these 3 numbers paired off. So 4 times 8 here. Then down 3 times -1. And then now 2 times 5. So that's what I wrote in there. So this is 32. Minus 3 is 29. Plus 5 is 39. There's the work. There's the answer. Now I'm going to take the first row times the second column and put them here. So 4 times 2 plus 3 times 5 plus 2 times 6. And that yields 35. And then first row times third column. That's why the amount of numbers that are here across have to match the number here that are going down. That's why these two have to match. You have to have them paired off. So the next one is 4 times 3, 3 times -1, and 2 times 8. So 4 times 3 is 12, 3 times -1 is -3, and then 2 times 8 is 16. So from there, if you add them up, you get essentially 25. This one, these 3 times these 3. So 4 times 4, 3 times 0, 2 times 2. 4 times 4 is 16, 3 times 0 is 0, 2 times 2 is 4. Add them all up, you get 20. The number's down here. Now the second row times each of these. So 8 times 8, -1 times -5, or -5 times -1, excuse me, and then -6 times 5. Add them up, you get 39. Then the next row times the middle column, 8 times 2, -5 times 5, and -6 times 6. That should be a 6 right here. Oh, jeez. Again, -6 times 6. So that would be what? 16 minus 25 is -9, minus 36 Negative 9, negative 36. That should be 47, actually. Sorry about that. Caught my mistake right there. Makes a difference. Here, 8 times 3, 24. Negative 5 times negative 1 is positive 5, is 29. And then negative 6 times 8 is negative 48, so it makes negative 19. That's what the product's here. This is the work. And ultimately, 8 times 4, negative 5 times 0, and then negative 6 times 2. So 32 plus 0 minus 12 is 20. This is your answer. This is the answer to the matrix. Okay, sorry about that little mistake there, but it makes a difference. Let me try another one here. This matrix is a 4 by 1. This is a 1 by 3. So see how the middle two numbers match? So the answer is a 4 by 3. So 4 rows and now 3 columns. Okay? So essentially, it means I'm going to have 12 answers. So, how do I say this here? This guy times each of these 3. So 8 times 5, 8 times 6, 8 times negative 2. Then I'm going to go to the second one. 4 times 5, 4 times 6, 4 times negative 2. Same, and then keep going with this. Third row. 3 times 5, 3 times 6, 3 times negative 2. And then finally the same thing with negative 2. Negative 2 times 5, negative 2 times 6, negative 2 times negative 2. Multiplying each of these pairs, those are my 12 answers. The third example here, number 7, notice here that the interior numbers don't match, because if I try to multiply these 3 by these 4, I have one extra one here that this one doesn't have. So I need a fourth one here. And you can't just throw zeros into a matrix, because the matrix is defined as kind of like a force or a vector or a direction. And so it has to be where you can add zeros in there. So number 7 is not possible. Okay? Number 8, 2 by 4, 4 by 2. Sorry, 4 by 2. These 4 times these 4. So 2 times 2, 3 times 5, 4 times negative 1, and 1 times 6. You add them up, you get 21. So let me do this a little quicker here. 4 plus 15 is 19, minus 4 is 15, plus 6 is 21. These values here are these 4 and these 4. So negative 6 plus 12 plus 32 plus 0. Then these 4 plus 2 times these 4. So negative 16 plus 25 plus 0 plus 36. That's what this work says. And ultimately, 24 plus 20 plus 0 plus 0. And those are my 4 answers. I'll leave this to you to practice, but ultimately it's 2 by 2. The 2 by 2 times the 2 by 2, the middle twos match. The outer twos tell you the size of the answer. You have 2 rows, 2 columns. So 5 and 4 times 6 times 0. Again, 5 times 6, 4 times 0. The next one, 5 times 7, 4 times 4. And the bottom, 2 times 6, 3 times 0. And ultimately, 2 times 7 plus 4 times 3, or 3 times 4. This is 30 plus 0, 35 plus 16, 12 plus 0. And then what? 14 plus 12, 26. So that's ultimately 5.7. Now, I want to go ahead and get you started in 5.3. That's the next section. It's what's called a determinant. Determinant has kind of like absolute value around the numbers that are inside the matrix, or it has a little parentheses around the whole matrix itself. As this is, there's a formula. The 2 by 2 matrix says if you have two numbers, A, B, and C, D, the determinant is AD minus BC. So ultimately, it is these two multiplied these two multiplied, and then subtraction in the middle. So it's AD minus BC. So let's practice here. These numbers, again, the determinant would be 4 times 2, which is 8, minus 5 times 3, 15. So 8 minus 15, you get negative 7. The delay there. But now, negative 7 is the answer for the first one. So now, the next way you can write it is absolute value. Again, that means determinant. So 5 times negative 1, which is negative 5. 2 times negative 3, which is negative 6. When you subtract the negative, you get a positive. So 5 plus 6 is 1. Sorry, negative 5 plus 6 is 1. So again, this turns into a plus. And so again, just a couple more quick examples here. These guys multiply to be 48. These guys multiply to be 48. 48 minus 48 is 0. So, and then I did a couple more here. Negative 3 times 6 is negative 18 minus negative 10. Two negatives make a positive. Negative 18 plus 10 is negative 8. Here, negative 12, 40. Formula says negative 12 minus 40. So it's a negative 52. So just kind of throw it out there. That was kind of formula. The determinant is just a number, just an answer that tells you if this matrix has an inverse or not. I haven't talked about inverses yet, but it's just a number that you calculate to kind of determine things later. For us, we're not going to go to the detail of all that because we're barely learning the algebra behind it. So when you're trying to get it, now this is the determinant of a 2 by 2 or greater, mainly a 3 by 3, a 4 by 4, etc. But my focus is a 3 by 3. There is what's called diagonal method also. If you learn how to do the diagonal method, by all means you can do this. But the diagonal method will not work for a 4 by 4, a 5 by 5, so on and so forth. This method I'm showing you will work for all of them. All of the square matrices that have a determinant, or they all have determinants, excuse me. So they have sign patterns. They start off with a plus, then a minus, and they alternate, then minus and plus. So plus, minus, plus. Again, they always start with a plus on the upper left-hand corner. Then from then on, horizontally and vertically, they alternate. So plus, minus, plus, minus, plus, minus, plus, minus, plus. And then 4 by 4, plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. Now, it doesn't mean that it's going to be a negative number. It doesn't mean it's going to be a positive number. It means if a number falls in this slot, you're going to keep the sign of whatever number that is. If a number falls here, you're going to change the sign, and so on. Wherever there's a negative, you're going to change to the opposite sign. That's all it's saying. I'm going to show you how to find the determinant using cofactors. So this is going to look a little confusing, but in the next page, I'm going to show you how this is done. So the cofactor of the ith row, jth column, that is a sign pattern times aij times the determinant of the matrix with the ith row and jth column removed. So to find a cofactor, essentially, we're going to take whatever number lives in that slot. We're going to cover up the row and column that guy lives in, and we're going to find the determinant of whatever's left. And I'll show you in a minute. The determinant of the matrix will be the sum of the cofactors of any one row or column. So we're going to have to find multiple cofactors. And I'm going to show you just how in the next problem. Okay. So if you're given a matrix, and they don't start circled. I circle all the numbers to show you the cofactors. So 5, negative 3, negative 2, negative 6, 4, negative 8, negative 1, 2, and 7. And this is the sign pattern that goes with it. So to find the cofactor, C11, he is a number that lives in A11. He's a number that lives in the first row, first column. So you see how this guy lives in the plus plot? So that 5, I'm going to keep the sign. I'm going to keep him as a positive 5. Okay? Now, because this 5 lives in the first row, I'm going to cover that row up. Because this 5 lives in the first column, on the first row, excuse me, I'm going to cover that row. Because he lives in the first column also, I'm also going to cover that column. So if you can see there, I covered the row and column that the 5 lived in. So you see those 4 numbers that survive? That 4, -8, the 2 and the 7, I'm going to put them here. And I'm going to find the determinant of those numbers, which is what we just did a little while ago. 28 minus -16. So it becomes plus 16. It's 44 times 5 is 220. That's how you find the cofactor of the 5. Now to find the cofactor of the next one, C12, this -3, notice that he lives in this spot, in the negative slot. So it doesn't mean that this is going to be negative. It means whatever this number is, I'm going to change it to the opposite sign. Okay? So this -3, I'm going to change it to a +3. And then the -3 lives again in the second column and the first row. So notice, I'm going to cover those numbers up, leaving you with -6, -8, -1, and 7. This is tough. Give me a second here. Those numbers, I put them in here, and I find the determinant. So -42 minus 8, that's -50. Then I multiply the answer by 3, and I get -150. Then, again, continuing on, C13 is the first row, third column. That's this guy. So the -2 lives in the plus slot. So I'm going to leave him as, I'm going to leave him the same sign. I'm not going to make him positive. I'm going to leave him as the same sign, -2. Then I'm going to close the first row, third column that he lives in. These 4 numbers are going to go here, and then I'm going to do what I did a little while ago by finding the determinant. So I'm going to do it, I did it above here. -12 minus a -4, that's -8. -8 times a -2 is 16. Then what I did here, I went through every single cofactor. So the next one is -6. He lives in the middle negative right there. So it means change him to the opposite sign, which is +6. Okay? And now I don't have something as thin, but imagine, if you will. Let's see, I can't. I'm going to kind of close this one off, the middle one. And I'm going to close the first one off, if you will. See those numbers, -3, -2, 2, and 7. That's what I put here. And then I configure the rule. I configure the determinant, -21 minus -4, which is -17, times the 6, and I get the next answer. And the middle one, 4, he lives in the plus slot. So I keep him as +4, but then I close the middle. I don't know, I know it's kind of thick there, but I kind of close the middle off. So I have the 4 corners. So see, 5, -2, -1, and 7. 5, -2, -1, and 7. So 35 minus 2 is 33 times 4, and so on. Then the -1, excuse me, -8, he lives in this spot, a minus. So I'm going to make him +8. I'm going to close up the middle row, and the last column. So I have 5, -3, and -1 and 2. And then I work it out. 56. Then this guy lives down here, kept him kept him as negative, close the row and column that he lives in, put those numbers here, and I got his answer. Then I proceeded to do with the last two, the 2, change him to a negative, so -2, close the bottom row, middle column. Those numbers that are left are these numbers here. And then ultimately the last one, the 7, lives in the plus slot, so it means keep him as 7, and then close the row and column that he lives in. So I have these guys. So I found the determinant. So I found all 9 cofactors. Okay? What I did, it's kind of a lot here, but the cofactors of the first row are C11, C12, and C13. So I added 220 to -150 to 16. I got 86. The second row are the ones that start with a 2 in the front. So C21, C22, and C23. So negative 102 plus 132 plus 56. Notice I got 86. Third row is C31 plus C32 plus C33. Those are these three numbers. Negative 32 plus 104 plus 14. Notice that that's also 86. So it's not coincidence. Then the first, if I'm looking essentially for the first column, it's C11, which is this number, C21, which is this number, and C31, which is this number. And if I add them, I get 86. Column 2 would be this one right here. This would be column, this would be 1, 2, C12, this number, C22, and then C32. Add them up. And column 3 would be C13, C23, and then C33 added up. Notice I got 86, no matter how I do it. So no matter what row or column I add, three cofactors on any row or column, I get the same answer. That answer that matches is indeed the determinant, and that's what it says down here. So instead of having to do all 9 answers, instead of having to get all 9, all I really need are any 3 in the same row or column. So I did all 9 to show you this concept. You know what? It doesn't matter what row or column you choose. So no matter what row or column you choose from now on, we're going to get the determinant by getting one row or one column. So instead of doing all of this work, we're going to assume that they're all going to be the same. And it works for all of them if you do this correctly. So having said that, find the determinant of each matrix. This is a given matrix. I'm going to choose the first row just for simplicity. So now, watch how it says plus, minus, plus. So I'm going to keep the negative 4. I'm going to change the positive 3 to a negative 3. And I'm going to keep the positive 5 as a positive 5. So keep, change, keep. Keep the sign, change the sign, keep the sign. So negative 4 is this one. So he lives essentially in the first row, first column, leaving you with those numbers, which are exactly these numbers. Then the 3 lives in the first row, second column, leaving you with these 4 numbers. Negative 6, 4, and 9, and 7, which are these numbers, and the 5, which lives in the last column, first row. So the negative 6, the negative 8, the 4, and the 8, which are here. So I'm going to do 3 determinant formulas. This is negative 8 times 7, which is negative 56. This is 9 times 8, or 8 times 9, which is 72, but the rule says take away. So this adds up to essentially negative 138, or 128. Then I'm going to multiply that times this answer, and that's what comes down here. So we get 512. Then this one's going to be negative 42. This is going to be 36, but take away because the rule says minus. That's negative 78. So I multiply negative 78 times negative 3, and I'm going to get 234 positive. Positive 234. Then negative 48 minus a negative 32. These two negatives make a plus, so negative 16. Negative 16 times 5 is negative 80. Add these 3 up, and I didn't realize this before I did the problem. It's unfortunate, but the determinant is that number. It's weird because I'm doing this video on a Sunday. God help me, but that's the answer. It just works out that way. That was just dumb luck. I don't know. I went to church today, so hopefully that's okay. Anyway, number 2 here. Again, because it doesn't matter the row or column you pick, just to be different from the first one, I went ahead and picked the middle column just to pick it. Again, you understand from the previous example that it doesn't matter what row or column I pick. So these 3 are here. Change, keep, change. Change the 4 to negative, keep the negative 2, change the 1 to a negative 1 to a positive. So close the middle row, the middle column, the first row. Get those 4 values and find the determinant. Those go here. Negative 3 and 5, 7 and 8. And the next one is the middle one. And my pen is kind of thick, but you see how essentially you have the 4 corners. So if you put where the 2 lives in the middle, like a little T in the middle, You see the 4 numbers in the corners. That's what survives here. And ultimately, the -1 is the bottom and the middle, leaving you with 6, -3, and -8 and 5. -6 and -3. Oh, geez. That's a -8, isn't it? Didn't catch that. So that makes this positive 24. Wow. I'm on a roll today, isn't it? So -30 minus 24 is -54. Wow, that makes a big difference. So this is minus 54. So 236 minus 16 would be 220. 220, or this is -16 minus 54 is 70, -70. 236 minus 70 is 186. Let's see if that's not right. This is -7. This is 166. So the determinant is 166. Again with the 66. Híjole. Again, just dumb luck. Okay, so that's essentially how you find the determinant of a 3x3. Now, Kramer's rule takes a little getting used to. So I'm going to stop here for a second. And in the next one, I'm going to go ahead and start with Kramer's rule.